This topic is called Finding Side Lengths and Angle Measures of Equilateral and Isosceles Triangles. Basically, you just need to know the facts about equilateral triangles and isosceles triangles. Geometry is a subject where they want you to follow your logic and establish conclusions based on what is shown or what is stated in a problem. So if we look at both these triangles, there's nothing marked on them. We can assume no angle measures, no sides. We don't know if they're equal to each other. We don't know anything. And we're not allowed to make any excuses or assumptions about that. Now, what would tell us if we're looking at this first triangle on the left that it's equilateral? One way to tell that we have an equilateral triangle is if they have tick marks through all the sides, because for equilateral triangles, all sides are what they call congruent. Congruent just means that they're equal in size and shape. For the second triangle, there's another way to tell that we have an equilateral triangle, and again, the word equilateral means equal sides. But another way to tell by looking at a triangle that it's equilateral is if they have these little angles. If all three angles are marked equal, this will also be an equilateral triangle. So all, and this is the symbol for angle, all angles would have to be congruent. So either one of these has to be shown before you can know that it is an equilateral triangle. You might want to put that in your notes, I'm not really sure. Once you have a picture with either one of these sorts of tick marks or congruent marks marked off, then you can make that assumption that it's equilateral triangles, and you can go from there and tackle the problem for whatever they're asking for. Another type of triangle that we're looking for learning about is called the isosceles triangle. And all isosceles triangles are equilateral triangles, for whatever that's worth. The definition is that two or more sides are congruent or equal. That's the technical definition. So an isosceles triangle, there's two different ways to be able to tell that a triangle is isosceles just by looking at it. Again, you can't assume, but you can look at a picture and see what's marked and go from there. So this first left-hand triangle, again, there's no marks. We can make no assumptions about it. We can make no conclusions about it. However, if we have the triangle and we have two sides, it doesn't always have to be the ones that are kind of quote-unquote up. Could be one down and one up. But if we have any two sides with those tick marks, that means that two sides are congruent. And right off the bat, we can, if we see a triangle marked like that, we know it's isosceles. Another way to tell that a triangle is isosceles is if we have two angles that are congruent. Once we have two angles that are congruent, then we can also say that it's isosceles. So we have two angles congruent. The relationship between these sides that are congruent and the angles that are congruent is if you have the two sides, I'm going back to this left-hand triangle here, if you have two sides that are congruent, the angles that you can then mark congruent are the base angles. It's almost like they're pointing at it. So these two would have to be congruent. For this right-hand triangle here, for this right-hand triangle here, these have, if we look at these two angles that are equal as the base angles, it would mean that these two sides are equal to each other. So again, they kind of point down to each other. So that's just the basics about isosceles. So let's do, and let's see, the first one, let's say that we're given this triangle here, and we have these marks. You'd have to recognize that you have three tick marks. That means that the triangle is equilateral. That's a conclusion that you are making. And then what the problem is asking for, let's say that this is M, and this is N, and this is P, that vertex down there. The problem is asking you to tell them the measure of angle M. For this problem here, you know it's an equilateral triangle. That means that all three sides are congruent, but you also know that all three angles are congruent. And the way that you do it, the total of a triangle is 180 degrees. You would divide that by 3 and you're going to get 60. Every single time you have an equilateral triangle, the angles are always going to be 60. Another type of problem they might throw at you again would be another triangle like this. We're going to label the axes Q and R and S. And then as far as what we have for marks on the actual triangle itself, we have that two sides are 9 and one of the angles is 50. So this time they didn't use any tick marks, but they did use the measure. So once you show that these nine, they're called legs, are equal to each other, that means that our base angles down here also have to be equal to each other. So again, we're going to use the fact that 180 degrees makes up a triangle. They gave us one angle that's 50 degrees. So 180 minus 50 gives us 130. And we have two angles left that have to share that 130. In what way do they share it? Well, they're equal to each other, so we're going to divide it by 2. So 130 divided by 2 is going to be 65 when you plop that in the calculator. So angle Q has to be 65, angle S has to be 65, and in this problem they wanted you to find the measure of angle Q, and that will be 65 degrees.